Hello. For my Lewis dot model molecule, I chose formaldehyde. Formaldehyde is the formula CH2O. Formaldehyde is made up of a carbon atom with 4 free electrons, two hydrogen atoms, with a total of 2 free electrons in the valence shell, and 1 oxygen atom with 6 electrons in its valence shell. To make the Lewis dot structure for this, you start with carbon in the middle because it's the most electronegative. You surround it with 2 H's and an oxygen. And you start by subtracting its bond pairs. That's 2, 4, 6 electrons taken care of. Oops, so minus 6 bond pairs, and now we have 4 plus 2 is 6, plus 6 is 10, minus 6 is, 4 plus 2 is 6, plus 6 is 12, minus 6 is 6 again. So we have 6 unbonded pairs of electrons, and we start by sticking them in the non-hydrogen outside atoms, and then we count if everybody has 8 in their valence shell who's not hydrogen. 2, 4, 6, 8, yes. 2, 4, 6, no. So carbon needs to have 2 more electrons. So the only way to do that is they get borrowed from a couple of oxygens and became a double bonded pair there. So that's what the Lewis dot structure for formaldehyde looks like. I'm going to do the same thing with a little 3D model. I have here 2 hydrogen atoms. These are actually foam balls, they're not really hydrogen atoms. 1 oxygen and 1 carbon. So again, we start with carbon in the middle and stick a hydrogen on each side. Find my toothpicks. And then we stick an oxygen at the other side. Now it's 2, 4, 6. We still have 6 valence electrons to use, so we add them out here. 6. We can see that carbon doesn't have 8 in its, so we got to get rid of one of these guys, replace it with a double bond. Now, as far as the shape of the molecule, remember that everything kind of repels each other, so it's the most stable state. Everything wants to be as far away as possible. So that means these guys are actually going to come drifting up here. And these guys will kind of like spread out here. And you can see what you're left with is a 3-pointed plane, or a trigonal planar molecule. Now, the electronegativity difference between the oxygen and the oxygen to carbon and hydrogen carbon make unbalanced dipoles, which means that the whole molecule is a polar. That means that the intermolecular force experienced by most experienced by by other molecules of formaldehyde will be dipole-dipole, meaning that the hydrogen will be weakly attracted over here to the oxygen. It's not a hydrogen bond because it's not attracted to free unbonded pairs on the central atom.